The interface of a modern frontier AI model projects an environment of complete neutrality. It is sterile, polite, and entirely empty, waiting to assist. Getting the interface to look and behave this way required massive financial and technical resources. Developers spent years identifying and aggressively filtering out explicit stereotyping, demographic disparities, and slurs that plagued earlier generations of artificial intelligence. When a machine outputs perfectly sanitized, even-handed prose, the human on the other end naturally makes an assumption. We assume that by eliminating hostility, the system has achieved true mathematical objectivity. But an examination of how these frontier models process complex inquiries reveals a different reality. A documented, persistent pattern of bias remains deeply embedded within the architecture of the latest systems. This remaining bias rarely looks like historical, crude prejudice. It appears instead as subtle, structural preferences, specific framing choices on contested topics, uneven evaluations of identical text, and systematic associations between certain demographics and specific occupations. A system that responds with perfect manners is remarkably effective at camouflaging its own subjective judgments. Beneath a veneer of manufactured politeness, the machine successfully hides a complex web of structural preferences. To find where these preferences come from, we have to look past the polished user interface and examine the raw, chaotic expanse of information the model consumes during its initial development. For years, the consensus was that AI bias originated solely from bad training data. The logic was simple. The model reads messy, uncurated human text scraped from the internet, and therefore learns human prejudice. That theory is now incomplete. The primary driver of model behavior happens in a secondary development stage, known as post-training, where developers actively tune the system to act helpful, harmless, and safe. During post-training, human raters grade millions of AI responses. They reward preferred answers and penalize others, manually dictating the model's behavior. These raters have their own perspectives. Over time, the machine absorbs the implicit viewpoints of the individuals running the grading process. A model fed perfectly neutral, clean data will still develop prejudices if the people evaluating its exams carry their own subjective preferences. The exact process engineered to align machines with human values has become the dominant mechanism injecting systemic bias into the system. We can observe the symptoms of this training mechanism when we ask models to act as an ultimate authority, grading or summarizing information for us. When evaluating text, frontier models consistently exhibit a bias toward length and authority. They systematically reward long, overconfident prose over cautious, empirically correct answers. They prefer the sound of certainty. They also exhibit distinct geopolitical biases. The historical framing of a contested global event changes depending entirely on the phrasing of the prompt, or even the country where the model was developed. Then there is demographic adjacency. If a user asks for advice and subtly changes a name in the prompt to imply a different socioeconomic background, the machine systematically alters its recommendations. These subtle symptoms cannot be patched with simple code. Fixing them requires defining what a culturally or politically fair answer actually is, a definition that human societies do not agree on. Any adjustment to satisfy one group inevitably alienates another. The presence of these symptoms confirms that the models have not eliminated bias. They have simply learned to regurgitate our preferred subjective realities, presenting them to the user as unquestionable empirical facts. A subtle preference in an isolated chat window is a minor curiosity, but deployed into automated digital infrastructure, it multiplies into systemic global consequences. AI increasingly mediates how people access information. A microscopic framing bias multiplied across billions of search queries shapes the global information environment in ways no individual user could ever detect. When these same models are used to moderate content across massive social platforms, a tiny threshold preference dictates exactly what kind of human speech is amplified or permanently suppressed at scale. The danger accelerates with the rise of agentic systems. AI judgments are now driving automated workflows, executing real-world tasks and making decisions without any human oversight to catch the subtle leanings. This structural leaning shapes the development loop. Frontier models frequently evaluate and generate training data for the next generation of artificial intelligence. This model-grading model loop propagates our blind spots into the permanent mathematical bedrock of future technologies. What begins as a harmless subjective preference in a research laboratory becomes a structural distortion of reality when automated and deployed globally. Resolving this requires looking clearly at the boundary between human intent and machine logic. The persistent narrative in the tech industry treats bias as a temporary technical glitch, something waiting for the perfect algorithmic patch to finally achieve pure neutrality. The reality is an inescapable trade-off. Mitigating one structural bias inherently introduces another. Flattening an output to make it completely even-handed removes its utility for substantive analysis. There is no universal baseline for truth. These machines cannot transcend human prejudice, because their entire definition of the word helpful was dictated by human approval. The behaviors that make them useful are the exact same behaviors that make them biased. We cannot code the human out of the machine. The bias is a permanent reflection of our own design. Navigating the future requires accepting that reality and carefully designing the boundaries of the machine's autonomy in our world.